is the cutting tool material. Then HSS, high speed steel. So under that there are T series, W series, sorry, T series and this tungsten. Okay, that is T series. So HSS. So under that HSS, if you see, there are two different series are there in HSS. What are those? One is tungsten. Sorry, not in HSS. Just a second. Yeah, in HSS, one is M series. Okay, M is a molybdenum. Then the other one is T series. Those things we have seen. Anyhow, overall, HSS will have very good toughness.
Sir,
Hmm.
you're not presenting screens.
Yeah, right now I'm not presenting. Okay, I will present once I start the new content. So carbon steels followed by HSS. HSS has two types. One is tungsten based T series and the molybdenum based N series. Then you have cast cobalt alloys. So cobalt is used as a binder, and we are using that as the tool material. And after that, we have seen various methods for attaching the insert to the tool holder. And we have seen various shapes of the inserts also: round shape, square shape, rectangle, okay, rhombus, etc. And after that, we have seen the shapes, okay, inserts. Inserts are made with the carbide, okay, tungsten carbide in general. So it may be mixed with some titanium and tantalum also. The tungsten carbide mainly, and some portion of titanium carbide, some portion of tantalum carbide may also be there. So those kind of tool inserts are very much used in industry, and these inserts may have different shapes, as I told you: circular, triangular, rectangular, rhombus, okay, different shapes with inbuilt chip breakers. Then these carbide tools can also be coated to
Sir,
improve
you're
their.
not presenting. Sir.
Yeah, I'm not presenting. Whatever we have, I am discussing now was already covered. Just a recap, okay, recollecting what has happened. Now, coated carbide tools. So carbide base will be there, on that you are coating with some other material like titanium nitride. Okay. And sometimes you may go for the sandwich coating. That means three layers will be there. Intermediate layer will be acting as the bonding agent between the upper layer and the bottom layer. Upper layer will have more hardness and wear resistance. That is what is required. And the lower layer will be sticking strongly to the base, that is carbide insert. So you have seen different types of coatings there. Then we have also discussed the ceramic materials. Okay, mainly alumina is the widely used ceramic tool material, and some portions of silicon carbide, etc., will also be there. Okay, now I am presenting. So I request CR to record this class.
Yes, sir.
So this we have seen in the last class: cutting tool properties of alumina ceramics. Now the next is ceramics. So as the name indicates, it is the combination of ceramics and metals. So that is ceramic. So ceramics, as we understand, it has good heat resistance. It has very good hardness and very good wear resistance, etc. But the thing is, it is very fragile or brittle. So it can break when you are applying some transverse force. It will easily break. So to reduce that tendency, these ceramides can be used. So ceramides are basically a combination of ceramic, that is titanium carbide, titanium nitride, etc. So these are used as tool materials, and metals like nickel, cobalt, ferrous, etc. as binder. Now, the manufacturing process for ceramides is similar to the process used for hot pressed ceramics. How are we preparing the ceramic tools? Through powder metallurgy method. So compaction, then sintering. So same method is used here also. So the materials approximately 70% ceramic and 30% metal. So most of it is ceramic only for the binding purpose, and to increase the toughness, we are using the metal. So strength of the ceramics is greater than that of hot pressed ceramics. So their strength is better. Therefore, ceramics perform better on interrupted cuts. So definitely, toughness is increasing due to metal component. So it can bear the interrupted force. Compared to ceramics, it is better. That is about ceramides. Now the next is polycrystalline cubic boron nitride. Okay, CBN is cubic boron nitride. Polycrystalline cubic boron nitride is the material which is very close to the diamond in hardness. Okay, and it is expensive also. So it is like, you can say, one kind of a synthetic diamond type. So CBN is similar to diamond and it's a polycrystalline structure and is also bonded to a carbide base. So CBN will be bonded to the carbon base, the carbide base. So here the thickness of this CBN, okay, insert that you are going to use, its thickness will be in the order of 0.5 to 1 mm only. Okay, very fine, very thin CBN insert will be taken and it will be attached to the carbide base. Now, while carbide provides a shock resistance, CBN layer provides very high wear resistance and cutting edge strength. This is obvious. So one thing is we cannot have CBN, entire CBN for the complete tool. It is very expensive. Even if you have CBN for the complete tool holder, its strength is anyhow less. Okay, strength means we are talking about toughness and the transverse rupture strength. So that is less. So for that purpose, we are using the carbide tool holder. Then you are simply attaching this small piece. Okay, so you are taking the advantage of both. CBN should mainly be considered as a finishing tool material because of its extreme hardness and brittleness. Okay. So you can use CBN for finishing process only because it is expensive. That is one thing. Okay, it is extremely hard and brittle. So if you are using it for semi-finishing and if you want to remove bulk amount of material, CBN will break. Understand? We cannot go for high depth of cut and low speeds. So that is not recommended. You have to go for very small depth of cut and very small feed using CBN. So that is finishing process. So use CBN for finishing only. Machine tool and setup rigidity for CBN as with diamond is critical. So similar to diamond, so machine tool and setup rigidity. So machine, there should not be any vibration during machining. Okay, it should be very rigid, whatever setup you made. Okay. Tool should be held very tightly. Very tightly means it should not move during cutting process. There should not be any vibration. So that is very important. Otherwise, the tool will break. Now, PCBN or diamond on tungsten carbide base. Okay, you can use tungsten carbide as base. And on top of that, you can use CBN or diamond. So like this, you can simply braze it. So yellow color one is the tungsten carbide insert. Okay. And in that insert itself, okay, to that insert, we are attaching this portion of the carbide substrate. So here you see. So this one here, this one is carbide substrate. So you are putting one carbide layer and you are brazing that to the tungsten carbide insert, and on top of that, on top of carbide substrate, you are putting polycrystalline cubic boron nitride or diamond. Okay. So this is how you will attach the PCBN or diamond to the tungsten carbide base. So here you can see construction of polycrystalline CBN or diamond layer on carbide insert. Carbide insert means generally tungsten only, tungsten carbide. Sometimes titanium carbide. Now the another type of tool material, diamond. So this is, as you know, is the hardest material known. And diamond tools have very high hardness. So we are saying that this is the hardest almost. Okay. Now, very low friction. So friction will be very less if you are using a diamond tool. Non-adherence to most materials, will not adhere to most of the materials. That is advantage. Ability to maintain a sharp edge for a long time. So its wear is also less. Of course, good wear resistance, these are not separate, all are interdependent. So those are the properties of a diamond tool. But if you are using diamond as tool material, some of the precautions, rigidity in the machine tool and the setup is very critical. TWF is tool, workpiece and fixture. So this should be very, very rigid. Now because diamonds are pure carbon, diamond is nothing but carbon only. So they have an affinity for the carbon in the ferrous material. This is obvious. So therefore, they can only be used on non-ferrous metals. So because diamond contains carbon, if you are machining a carbon-based metal, So obviously there will be diffusion. Okay, that will finally uh, deteriorate the shape of the cutting tool. So machining will not be proper. You should not machine carbon-based metals. So generally ferrous metals will have carbon. So you machine non-ferrous metals. So this is one more thing. Diamond has a tendency to revert at a high temperature, about 700 degrees Celsius, to graphite or oxidize in air. So at around 700 degrees Celsius, diamond is nothing but the highly pressurized graphite. Okay, is diamond. Now, if you heat it, okay, diamond around 700 degrees Celsius, so there is a chance that so it will go back to the graphite stage. Okay, and it may oxidize in air also. So that you have to take care. During cutting process, temperature should not go very high. That is important. Now, diamond cutting tools should only be used for light finishing cuts of precision surfaces. This again is true in case of PCB also. PCBN also. Again, because its transverse rupture strength is very less, so you cannot use for high feed speed and high speed is okay. High feed and depth of cut, if you are using the cut diamond tool, it will break. So feeds should be very light and speeds are usually in the excess of 1500 meter per minute. Very high speed. Okay. Compared to the speeds that you have seen 30 meter per minute, 40 meter per minute, like that. Okay, earlier for carbon steels and HSS, the speed range was very less. Now here it is very high compared to that. Diamond is very brittle and costly to shape into cutting tools. So it is very brittle, so you have to handle it very carefully. Okay, if it falls down like okay from some height, or if some impact load comes onto that tool, it will break. Okay, and shaping the diamond tool is very difficult. Okay, because the diamond is very hard. So if you want to cut that diamond, okay, it is a very difficult process. So polycrystalline diamond tips bonded to carbide base. So these are some examples here. So polycrystalline diamond material bonded to carbide base. This is the carbide tool here. So this kind of a diamond insert, okay, is attached through brazing. Similarly here and for all the tools. So generally, approximate cost of cutting tools for various materials. Okay, these are anyhow old prices. So, but a range, the sequence will be like that only. If you are talking about high-speed steel tool beads, cost is around $2. Okay, their size is also given 1/4 square. Okay, into 2.5 long. Okay, that size designation for that particular insert is given. Half square into 4. So it is about $7. Carbide tipped tools for turning $2 to $4 based on this size 1/4 square, 3/4 square. So 1/4 means 1/4 inch. Okay. Now carbide insert square 3 by 16-inch thick. So it is about 9. So you look at the material. HSS is very cheap, followed by carbide inserts, then coated carbides, ceramic, then CBN, diamond coated inserts, then diamond tipped inserts in that order. So diamond is very expensive, CBN is also expensive. So if cheap tool material can remove the material from our workpiece, we'll use that only. So only in special cases where you are dealing with very high strength materials, then only we'll go for those type of tool materials. So that's it. This is about various tool materials that we use in machining process. Any doubt here? So today let us conclude this. We will discuss the fresh topic tomorrow. It is thermal aspects in machining. So any doubt in today's topic? We discussed ceramides, CBN and diamond. It is this topic, whatever is there, it is almost a theory type. Okay, there is no single equation, nothing. But you have to understand why the properties are varying. So from carbon steel to the diamond, so the machining speed is increasing gradually, and the toughness of the tool material is decreasing. Hardness is increasing. Brittleness is also increasing. Okay. So in that order, we have discussed the materials, tool materials. And of course, they are becoming expensive also in the order. Those are the properties you have to understand. That's it. Anything to discuss?
No, sir, clear.
Okay, so let us close today's session. Of course, half an hour is left, but we'll start the fresh topic tomorrow.
Thank you, sir.
So all of you prepare well for your minor.
Yes.
Yes, sir. Thank you, sir.